So we are going to be talking about rational exponents. So this is when you have a fraction as the exponent, or you are creating the exponent that has a fraction. And the rule is you have your power over your root is your exponent. And so let's look at it going from a fractional exponent to what it looks like whenever you have it. So this is the same thing as the fourth root of x cubed. Or another way of writing that is the fourth root of x, the whole thing cubed. But let's look at it from the other perspective. So let's say I gave you the radical. Let's say I gave you the square root of x to the fifth. And I asked you to find it as a rational exponent. So what's understood to be here is a 2. So you'd have 5 over 2 as my exponent. So let's look at this first problem. It's not as simple as just converting back and forth. The number that's underneath the radical is not prime, and so therefore I need to take and find out what raised to is 64 raised as a prime number to it. So a couple of ways you can come about it is you can take 64 and find the prime factorization by dividing by 2 all the way down until you get to only prime numbers. And there's nothing besides a prime number that can divide into 2, so I'm done at that point. So 64 is 2 to the 6th. Another way some people think about this is the same thing as 64 is 8 squared. And 8 is 2 cubed. And so when we multiply our exponents, we get 2 to the 6th. Both methods work to find it, whatever one works for you. So 64 is 2 to the 6th. So I have the 8th root of 2 to the 6th raised to the second power. Now I need to take and simplify these exponents. When you raise a power to a power, you multiply the exponents. So 6 times 2 is 12, so that's 2 to the 12th. Now I'm going to convert this into a rational exponent. So 2 to the 12 divided by 8. This can simplify by dividing both of those by 4, and I'd have 2 to the 3 divided by 2. So in this next one, we have 81x squared to the 3/4 x, or to the 3/4 power. So step 1 is going to be to create and get your 81 in terms of a prime number. And so 81 is made up of 3 times 27, which is 3 times 9, which is 3 times 3. So another way of me writing this is 3 to the 4th power, x squared, raised to the 3/4 power. Now I'm going to distribute that 3/4 to both exponents. So I have 3 to the 4th raised to the 3/4 power, x squared raised to the 3/4 power. And our rules for of exponents being raised to a power is we multiply the exponents. So if I have 4 times 3/4, I need to think of this 4 over 1, which when I work this, this cancels out, giving me just 3. And so I have 3 raised to the 3rd power times, I'm going to do the same thing with that 2 over 1 times 3/4. The 2 and the 4 can reduce, give me 3/2. So x to the 3/2. So this is just a whole number. I can go ahead and find out what 3 to the 3 cubed is, and that's Looking back 1, 2, 3, that's 27, times the square root, which I don't need to write that 2, it's understood to be there, of x cubed. And that's me rewriting it as a radical. If the problem had asked for me to write the answer in simplest rational exponent form, I would have taken and simplified this number and had the answer be 27x to the 3/2. So read the directions and see what you need the answer in, if you need it in radical form or if you need it in exponential form. Another thing that is showing up in these assignments is sometimes we'll have a negative exponent. And if you have a negative exponent, all that means is that number has been moved to the denominator, or moved from the denominator to the numerator. So let's look at number 4. So I have a power being raised to a power, so I'll multiply. And so 3/5 times 4 over 1 gives me 12 over 5. That can't simplify. So my answer is x to the 12/5, which when I rewrite that as a radical, is 5x to the 12th. 5th root of x to the 12th. Here's another one where we need to do some rules of exponents first and then convert. And so anytime you have anything raised to the 0 power, that's the same thing as a times 1. So let's look at this, and we have 4 times 5 times 1, and that gives us 20. M second times m to the 4/3. That means I need to add those exponents. And so 2 plus 4/3. I want this in the simplest fraction form, so I need to take and multiply to where we have a common denominator. So I need the 3 in the denominator, so that means I need to multiply by 3 over 3. And so that gives me 6/3 plus 4/3, which is 10/3. So 20m to the 10/3. If I wanted it in rational exponent form, I'd stop here. If I want it in radical form, that 20 hangs out in the front. The 3 becomes our index, m to the 10th. Let's get a couple more. A power being raised to a power means that I need to multiply those. So 4/3 times 2/5. 4 times 2 is 8. 5 times 3 is 15. And so that gives me x to the 8/15. So the 15th root of x to this 8th power. So on this last one, we are dealing with fractions, and so that means we need to reduce the coefficients and subtract our exponents. This is understood to have a 1 as the exponent. So 12 divided by 2 will reduce, giving us a 6 over 1, which is just the 6 stays in the numerator. Our highest power is in the numerator, so we are going to subtract that 1 up here. And so 5/4 minus 1, which the best way to write that 1 is has to have a common denominator, so I want to write it as 4 over 4, because that's the same thing as 1, which gives me 1/4. So when I simplify this is 6x to the 1/4. Now I'm going to convert x to the 1/4 into radical format. So that's the 4th root of x to the 1st. I do not need to write that first power though.